Hello, my name is Anthony de Almeida Lopes, and I'm going to be speaking about escalating privileges in Unix by backdooring Libc in various methods. I work for Outpost 24 in Sweden. We're an automated vulnerability scanner for networks, and I am a software developer as well as a security researcher. Sorry about my slides here. I'm going to have to kind of move around because it's too small to see otherwise. So what I'm going to be talking about is mostly on Unix. The su command, new role, sudo, all of these support specification of commands to run in another security context, and there's a little bit of a problem with how this is actually done. This can be abused to escalate privileges, and I want to clarify that I'm talking about escalating privileges. I'm not talking about without any exploitation at all. You should already be in the system as a regular user, say exploiting Firefox or Mozilla or something like that. So this is just how to get root after you've already compromised the system in some way or another. And I'll give you a proof of concept demo with using ptrace to inject code into another process in the same security context to get to the next security context, as well as using the typical LD preload to do this as well. Okay, my hypothesis here is that work to be executed in a new security context should not be scheduled in the previous security context. And I'll explain why I think this is true. The theoretical support for this is that, well, you already know that what SU does and how that works. And basically, the arguments to SU, new role, any of these things can be modified because they exist in a memory which is only part of the previous security context. So say my user's name is user or Tony or something like that, which exists in that, and I run shells in this, and there's Firefox in that as well. And these both exist in the same security context. So my shell can edit the memory of the Firefox, and the Firefox can edit the memory of that. And there are various ways to do this. I chose either ptrace or LD preload. And I think you guys can see this kind of graph here. Basically, this is the specific example of using ptrace. But basically, a user runs a shell. The user shell is infected by a Trojan. This comes from the Mozilla or whatever else is infected. The user requests an action A to be executed in the security, the privileged context. The Trojan is then activated and modifies what they've requested to be done, like, say, replacing action A with action B, or maybe a combination of both, so you're a little bit more covert about that. The user then authenticates, and now you're actually using SU. You're actually in that, and it's set UID binary, so there's nothing more to attack there. And then that's automatically escalating privileges if you typed your password correctly, and B is executed, which is not obviously what the user intended to do, and eventually you go back to the original security context. Some background for this: the Trojan property is not new. This has been in login and various things. People replace their login prompts with other things to steal passwords and stuff like that. Typically, these things require a little bit more of attacker interaction with their target. However, this particular approach that I'm taking completely automated, and it still exists. For the most part, on local terminals anyway, you have if you have physical security, you don't exactly have this problem, but we're talking here in a network context. Cross-site scripting also seems to be like the web's new Trojan login, so that's also a related problem. And basically what it comes down to is that there's a severe lack of trusted path in the common Unix security model. And I'm saying common because some systems actually do support this to some degree, and I'll talk about that later. This is interesting because it's not just SU and sudo that have this problem. The new role, as I said, in SE Linux, one of the up-and-coming NSA's secure mandatory access control-based and role-based access control and so on, system for locking down Linux also has this trivial little flaw in it. You can have a great policy going, but if you can execute commands that the user didn't intend to execute in the first place, you could still do things within that policy. Yeah, and one of my points here is that vulnerabilities and unprivileged applications still matter, and this is just one demonstration of why that is true. I do a lot of vulnerability research, and I get a lot of the time like, oh, this doesn't matter. You found something in some really common application that's not set UID. Or I hear it from the other side. A lot of researchers are like, oh, where's the set UID binaries on this system? That's what the first thing they look for, but I really don't think that's necessary if you just have a small amount of patience, because some people are going to use sudo, su, new role, whatever to do some administration tasks. If it's a server, you're going to run Apache eventually. If it's not a server, it's a desktop, you're going to run shutdown eventually. And you have to do these as a privileged user, usually. This is changing with the advent of PolicyKit and SE Linux as well. But in the most 99% of the case, this is the way people are using their computers, their Unix computers these days. And I also want to point out that I think that in policies for SE Linux and other mandatory control systems, mandatory access control systems, the userland applications, the unprivileged applications, should be locked down with the policy as much as the privileged applications are. So I'd really like to know why people think it's okay that Mozilla can read my GPG keys and my SSH keys, but it's not okay for Apache to do such and such other than just serving web pages. I think it should be equal on both sides. I'm not sure why it's not that way, especially for desktop systems like Fedora and stuff like that. Why do we have a targeted policy for Apache? People aren't typically doing that on their desktops. They're usually running Firefox and things like that. And these applications really shouldn't be interacting except for through the communication channels that they're allowed to. People are still using SU everywhere. I use it. People are still using sudo. That seems also really common. Other applications are built on top of these, like GKSU, KDESU. There's a new GNOME one. I'm not really sure what it's called. It's integrated in Fedora or Red Hat or something. PolicyKit, I'm not going to talk too much about it because I really don't have a lot of experience, but from the first look at it, it seems that it's at a similar state to what new role is, and I'll explain that, so just keep that in mind. But definitely more research should be done about PolicyKit and these other kits that are from freedesktop.org managing authentication, console login, and that kind of stuff. So you guys probably know what SU is, considering. But in case there's any Windows people here, SU is a setuid Unix program that allows you to switch to an escalated privilege context or to another arbitrary user. Typically, without any arguments, it just gives you a shell. With arguments, with this specific argument -c, it'll give you, it'll execute that command that you request and exit immediately. So let's move on. New role is a program that allows, this is specific to SE Linux, by the way. This is not common for most distributions, but like I said, Fedora and some other ones that are doing the SE Linux thing now are using this. And it looks like from the targeted policy, it's basically the same as SU, more or less. It has the same problem as SU, but it's typically more restricted because what you can and can't do in the new role depends on what the policy is. So, for example, someone could have a policy where you're allowed to run ls, and if that's and you could also say view images as root. Okay, these are ridiculous examples, but anyway, you can't go and say, oh yeah, I want to change your ls to be something like I want to open a port. That's just something that's policy dependent. However, it's still strange that you would be able to change what the user is intending to do from viewing directory listings to viewing images. It just doesn't make sense. Yeah, so I think I just covered most of these points. One of the interesting things, controversial, I guess, is that in SE Linux and other systems that are similar to this reference monitor-based system, policy is supposed to be separated from mechanism. And, well, I'm going to talk more about this in the resolutions of the problems, the remedies for the problem. But basically, the policy for fixing this in SE Linux can be quite daunting to actually do this. And if anyone knows any policy for SE Linux, it's quite daunting in the first place. So it may be nice to actually just remove this as a potential solution. But I'll go into that more later. Sudo is just like SU. It has like a really limited type of policy thing where you can say, like, this user can run this command. And basically, instead of using the root password, it'll typically authenticate against their password, although I think that's also configurable. Sudo has other problems, has a long history of problems. People write policies that don't really make any sense. For example, like you can write a policy, this user can use VI, and what that means is you can just do bang in the thing and run a root shell or whatever context you're in. More or less, there's like a million programs that have this problem. You can do all kinds of other stuff as well. It's just not that secure, but my recommendation here would be to audit the applications that you're allowing users to run in a privileged context. Details of the problem. Okay, so all these programs, one of the things that have in common, they all have different forms. With SU, it's -c. With the other one, new role, it's putting it just after the rest of the command and so on. All this stuff is stored in in the previous contexts, the unprivileged contexts memory area. And like I said, so is the other vulnerable, the exploited application is also in this same memory space, more or less. Yeah, so that covers the first 3 points. Modification of this memory can be easily done by placing a Trojan in the execve code in libc. So I know you guys are a lot of technical guys here, so I'm just this isn't on my slides, but I'll just explain a little bit about that. Basically, using ptrace, I inject code originally just to allocate memory using random stuff like return to libc and stuff like that, and basically allocate some memory, put my code there, and then memprotect libc so that I can actually overwrite the int 80 for going into the kernel with jump to my code that I've just allocated, and then fixing it all up, and then detaching so it can run. So this is what you do to all the shells and anything that can run a shell and all that kind of stuff. So whenever someone runs execve, su, whatever, the -c and the rest of the arguments will be appended. So I just want to make it clear that these are not attacks on the programs I'm discussing here. These are attacks on the way that the shell actually deals with this stuff. So I think that might be kind of confusing because everyone's like, well, you can't ptrace a setuid application. Well, I'm not. I'm attacking the actual shell that the user runs the SU from and changing what they requested to do. Yeah, and you can also do this with LD preload, which is obviously not quite as exciting. Okay, so this is the details of just the generic algorithm for it. You use proc or something like that to find all the processes that are shells. What starts with -sh, what starts with /sh, what starts with bash, whatever. Just look for all of them. Attach to each one and do as I just described, backdooring execve. Now when here's a perfect example of how this works. You want to run su-c cat varlog messages as a typical thing system administrators would do. And instead, what you get is I inject this bad code here, and then also you're catting the messages there anyway. So this bad code is any shell script or program or whatever that the policy or lack of policy allows you to run. Details of the LD preload. The ptrace is always more interesting to me, but if anyone is to actually make malware out of it, I would guess this is the way they do it since it would be so simple and reliable. Basically, Mozilla or whatever that gets owned, it basically just overwrites or appends to their profile, their shell profile, and export the LD preload to the location of the path. One of the reasons I did the ptrace thing is because it never actually touches the disk and doesn't leave any resident evidence. However, this probably would, but it would also be most likely more reliable. And so you have the exact same thing here. Now this doesn't affect all current running shells as the ptrace one, but any shells that they've invoked after their profile has been modified will be vulnerable now. Okay. I think right now I'm going to show you a little demo here, which is going to be tricky because I built this microphone. Hold on a second. So this is an uninfected shell right here. I'm going to just su to root to show you that. Nothing abnormal happens at all, so that's okay. Now I'm going to run the ptrace program here. You can just pretend this screen right here is like from within the context of Mozilla or whatever. I'm sure you can see how that's possible. And the number right there is the process ID of the shell that I want to attack. I just run this, a lot of output there, a lot of debugging output. Then we switch over here, and now when I do SU, I've just executed ID in there. On the root, as you can see, it ran as root. So this is not a trick. It actually does work. And just a second, and I'll show you the LD preload version of this as well in a new shell that's not infected. So. That's the important part right there. You need to actually run a new shell for this actually to affect it, because the LD preload affects the application at the beginning of its runtime. You can't do this while it's running. Okay. And there you have another little gem there running ID, and you can see it's running as root, obviously. Okay, so everybody got that. These demos I will show at the end are these demos are available at the website. Can everyone read that, the first URL there? Is that okay? If not, come up and ask me later. It's part of a larger project I'm doing to basically prove that preventative security measures are probably better than these retroactive measures, such as antivirus. Anyway, I won't go into that too much right now, but anyway, all this code that you saw is available there, although currently what's there at this moment is older than what I'm about to post after this talk. But you can get the basics there anyway, and there's some descriptions and documentation. So workarounds and solutions. How do we solve this problem? I think, well, I'm just going to say it before any of this. I think the most obvious thing is to remove the mechanism. I think that as my hypothesis says, that I think that work to be run as a privileged user should be scheduled by someone who has already authenticated themselves as a privileged user, not by someone else previously who may or may not be able to authenticate anyway. Now, for SE Linux, like I said, apply targeted policies to all network-facing applications, and these days that basically means everything. That means Bash, that means your document viewers, your PDF viewers, your email client, everything. And I don't think this is a terrible amount of work. I mean, it's obviously a lot of work, but it's not. I don't think it's a stretch to actually do something like this. And instead of using this is actually almost the same point, but just use a targeted, a strict policy instead of the targeted policy. It can find everything instead of just specifically what you think should be protected, because one of my points is here that I think everything should be protected. Moving on from that, I want to say that for sudo, I think it is possible to actually secure this to some degree with that, if not completely secure it with that. I think if you have a strict enough sudoers file, and you have, especially if you have more than one user for different tasks you want to accomplish. For example, you have a user specifically for RPM and stuff like that, and you audit all the applications that are done for that. I think it might be quite a bit of work, but I think it's completely a solvable problem. For SU, I'm definitely going to recommend that the best thing you do is remove the -C option from that. And I'm not really sure what else you can do. There's not really any kind of policy for it or any kind of way you can control it that much. Sorry, I'm going to go right to the third option there. You could use PAM modules possibly to do this. There are none that I know of that exist for Linux to do trusted path. However, Trusted Solaris also has their own implementation of a trusted path module. I'm not completely sure if it solves the problem, but I definitely think it should be looked into. And like I said, obviously the second option is to use a lockdown SE Linux or some variation of some pseudo policy that would actually fix this problem. Like my hypothesis, my conclusion is that SU new role, blah, 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 all these should support the specification of and sudo support the specification of a command to run in the new security code before authentication. This can be, we've demonstrated that this can be used to gain privileges without too much work at all. A proof of concept using, okay, that was already done. Anyway, I just want to thank you for this. I'm really interested in people's feedback about this as much as possible. I'd like to know whether you think this is a big deal or not. I've been working on I've been working on this for about 2 years now. This is, well, not the entire time, obviously, but so it's not exactly new to me, and it seems obvious to me, but I'd like to know if there's anyone here that does policy or does any kind of work on distributions or something, what they think about it. I want to say that, I'm going to, again, point you here to my project that I'm working on here. It's just like some code to support that it's probably a good idea to use mandatory access systems and just various parts of trusted computing that probably should apply to desktop computing as well. The source code is there, of course. Then I want to say in June 2007, which seems to be about the exact same time I thought about this, we both thought about it independently. He used ptrace to attack sudo with a program called sudojump. And I think you might be able to see his homepage there. You can go check it out. You can go see the mailing list thing. And what I actually suggest is that you search for his name and look at all the places that he posted this on, BugTrack, on just everything. The insecure.org archives, like this posting shows up in about 10 different places, and there's one response. And I think that's probably not an acceptable thing about in the security community, since this is such a problem. Well, in my opinion, it's such a problem. But like I said, I'm waiting for more feedback. And like I said before, in Trusted Solaris, you have the PAM TP auth PAM module, and it's not completely clear whether this solves the problem, but we should definitely check that out and see what we can do about that in Linux and BSD and Mac OS 10 and the rest of the Unix platforms that are affected by this. So I'm just going to end right there, and if anyone has questions, please feel free to raise your hand. Questions? Well, there's several levels to trusted path, actually. One of them is that you invoked the program you intended to invoke, which is the case here. You did, in fact, use the sudo from user bin su or whatever. And there's various ways of compensating for that. For example, doing checksumming on the actual executable that you're running, or sorry, digital signatures is probably even better. But that's the first level of trusted path, and the second level of trusted path here is has that program been altered? Has its behavior been altered in a way that you did not intend? So if you're gonna, I don't know how you would get a wrapper in there if you were actually running /user/bin whatever. You would just be modifying the shell in a very similar way to this. Like I said, there's more of the ways to do it than what I presented. Yeah, okay. Well, in trusted computing, it wouldn't actually respect your path. So that's kind of what I'm saying, is you'd have to invoke the specific application you intended to. Okay. Sorry, I couldn't hear that. Yeah. Okay, actually, I agree with you on that completely. Yeah, you're right. And I heard a few other things too, like someone suggested immutable memory as well, and I think that it would also be vulnerable to the problem you're discussing as well. I think Trent, his name is Trent Waddington. One of his solutions was just to disable ptrace completely, which I'm not really sure that the problem is ptrace. Honestly, I don't really know what the real solution is here, but that's definitely an alternative as well. Disable LD preload, disable ptrace, that kind of stuff. But I don't know. I think maybe that a policy affecting all of unprivileged applications would probably help you, though. It just might be difficult to do that. Yeah.
First, I do find it very interesting. What you're saying is the easiest view of this, in my opinion, is like every granted prime relationship that's already present is going to be a source of further intrusion into the organization.
Yep.
Like you just need like one stepping stone to get into.
Yep.
And as you're putting it, instrumentation is what you're doing.
Yeah.
It's very powerful tool for any kind of prime relationship.
Yeah.
Abuse, like storing passwords. We know it. We know it's possible.
Okay.
Like even storing temporal credentials like server secrets or temporal IDs or whatever. And I do think that disabling the debugging features of the operating system maybe is not a solution.
Yeah.
But we still need to find a way how to do it without the debugging features.
Exactly. And I'm not an I think it's pretty obvious. I'm not an expert in trusted system. I'm just an end user of it, and so I really don't know how to solve the problem in the best, most appropriate way. But yeah, I agree with you. And sorry, who was saying that about sniffing the password? I was going to say that's also an issue of trusted path to the path from your keyboard to the application you're talking to. And Linux has some support for this, typically through hardware and some complicated drivers. But there's a lot of papers on how that works. And this is kind of assuming that all those are in place. Obviously, they're not on my system, but the trusted path with the actual path and the trusted terminal as well. But this would still affect that after that. Any other questions? Okay, thank you.